Hello guys, we are back with our next lecture. In this lecture, let us go through the next topic. So this topic is a Bellman-Ford, guys. So Bellman-Ford algorithm. So this is discovered, or this is designed by two scientists. So the first scientist name is Richard Bellman, and the second scientist name is Lester Ford. So Bellman-Ford, with their second name, so they have created the name of this algorithm, guys. Okay, yes. So if you recall, I told you one important point with respect to Dijkastra. So in Dijkastra, I pointed that you cannot do you cannot do shortest all pair, it's not all pair shortest path, it's single source shortest path for negative weights, right? If you recall, yes. So that is a possible with Bellman-Ford, and there is one more condition, that there should be no negative cycles, guys, negative weighted cycle. So if there is a negative weighted cycle, it will recognize it, that's it. Okay, so anyway, I'll be discussing about negative weighted cycle and all those things, so don't worry. Okay, yes. So first let us go through what is a negative weighted cycle. Okay, so assume that you are having three nodes, guys. So the first node is S, and the second node is A, and the third node is B. Okay, so this cost is 10, this cost is 20, and this cost is minus 31. Okay, so assume that you started at S. Okay, so you will say from here the cost to A is 10. So from here you will say the cost is 30, because 10 plus 20 is 30. So from here you will be saying from B to A the cost is 30 minus 31, that is minus 1. Okay, so minus 1 plus 10 is a minus 9. Minus 9 plus 20 is plus 9. So plus 9 plus 20 is a 29. So 29, here it will become minus 2. So this is a never ending loop, guys, to be clear. So if you ask me, I'll be going till any time, you can just continue like this, right? So this is a negative weighted cycle, guys. So if you calculate the total value of this, you do addition, you will get a minus 1. So each and every cycle, it reduces itself by minus 1 each and every time. So this is the negative weighted cycle. So the solution which Bellman-Ford say for this particular thing is, he will say false or he will return 0 for these kind of problems. So if your graph is having a negative weighted cycle, it will return 0 as the result. Got it? Yes. Okay. So now let us go to the theory. So it is an algorithm that computes the shortest path from a single source vertex to all the other vertices in a weighted digraph. Okay. Digraph means directed graph. Okay. So the first thing that you should remember, is it is slower than Dijkastra algorithm. So if you compare the speed with respect to both of them, so this algorithm will be a bit slow, guys. Okay, and capable of having edges with a negative weight. So this is an advantage, you can say. Okay, yes. So now your first question will be, okay, so first before going through the algorithm, first let us have an example. So most of you will be thinking in that way, right? Yes. So obviously let us go through the example first, guys. Okay, yes. So let me note down the question. Yes, A, B, C and D. So here the cost is 6, here the cost is 5, here the cost is minus 2, here the cost is 8, here the cost is 7 in this direction. Okay, so here the cost is 9, here the cost is 7, here the cost is minus 4, here the cost is minus 3. Okay, so I have just drawn the graph, guys. So now let us start solving it. Okay, so this is a really easy problem if you ask me. So the only thing is you should have some common understanding, guys. So this topic, or this single source shortest path, is also almost similar to Dijkastra with some slight change, guys. Okay, yes. So you will understand what is that slight change now, so don't worry. Okay, yes. So let us write the same matrix. So D of V and pi of V, and what are the vertices you are having? Yes, A, B and C and D, right? Yes. So the thing which is different is, so you will understand, don't worry. So initializing will be doing with infinity and with nil, right? So minus, 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 right? Yes. So let us start. Okay, so what is our start vertex? So assume that we are starting at S, guys, and we need to find for each and every vertex the distances. Okay, yes. So what you will do is at start, so you will update it to 0 and you will keep it nil. So from S, where you can go, guys? So from S you can go to A, right, directly? Yes. So you will update this value to 6 and from S you can go. Similarly for D also you can go. So with cost of 7 you can go to S. Okay, so previously when we are using a Dijkastra, we used to cut off this, right? So you will not going to do anything, but here you will not strike it off now, guys. You will strike it off later on. Okay, so for now, yes is done indirectly, right? Yes. Okay, so now let us continue. So now which is minimum, guys? A is minimum. So now let us continue for A. So what is A? So from A you can go to B at a cost of 5. So till here the cost is 6 for now. So 6 plus 5 is 11, right? Yes, and with the help of A you can go there. Okay, so from A you can go to C also. So if you observe 6 minus 4, so hence the cost of C will be 2, right? Yes, so with the cost of 2 you can go till C. So with the help of A you can go, right? Yes. So from A you can go to D also. But 6 plus 8 will be 12, right? So the D cost will be really high. So let us avoid it. Okay. Yes. So now you are done with the A also. Okay. So what are the costs which you updated, guys? So that's what you should always keep a concentration on. So we updated the value of B, C and D, right? So let us take C first of all. It will be easy, right? Yes. So from C, the cost is 2. From C, you can go to D, go to B at the cost of 7. So 2 plus 7 is 9. So at the cost of 9, with the help of C, you can go. Right? So this is done. And which cost you updated? B cost you updated. So now let us go through B now. Okay. So from B, you can go to A by minus 2, right? So 9 minus 2 is 7. So that's not a fair thing, right? Yes. So there is no update in it. So from B, where else you can go? Okay, I think you cannot go anywhere else, right? Yes. Okay. So now you are done with this also. So now let us go to D. Okay. So from D, so the cost at D is 7, right? Yes. So from D, where you can go to C. So 7 plus 9 will be okay, 16. So C cost is really less, so don't increase it. So from D, you can also go to B. So 7 minus 3, the cost is 4. So now this has been reduced, right? With the help of D. Okay. So now this is also done, but D has modified B, right? Yes. So let us now check from B. So from B, with the cost of 4, where you can go? You can go to A by doing minus 2. So this will be 4 minus 2 is 2, right? So from C you can go, from B you can go there, right? Yes. Okay. So now A has been updated, right? So from A, where you can go to C. So if you do 2 minus 4, so you will get a minus 2, and the way you are going is via A only. Got it? Yes. Okay. And you can also go to D also. So what is the value? So 2 plus 8 is 10. So already we are going to D at 7 cost. So this is the minimum. So now there are no changes, right? So now start cancelling the values which are minimum, or this is the final values, guys, in simple words. So from S to A, the minimum cost is 2. So I'll be writing it here. So from S with a cost of 0 you can go. From A with a cost of 2 you can go. From B it is 4. For C it is minus 2. For D it is 7. So if you want, you can track back the exact paths also. To A, how you can go, guys? So A to B. Okay. So from to A you can go via B. Okay. From B you can go via D. Okay. This is a bit Chinese process. D, from D you can go to S. So this is the path for our A. So in that way you can find the paths for each and every one. So now you got an idea, right? So how exactly Bellman Ford is working, right? So here we are having negative weights, and even we got one value cost as minus 2. So few of you might be saying that, okay, so is it really possible in real time example? So if you take the example of Tesla car, and even I don't remember which company, but even one more company's car has started this, guys. So whenever your car is going downhill, okay, so if it is an electrical car, okay, instead of discharging its battery, it will charge its battery, guys, because it's going down, right? So it will have some movements and all those things. So with that, it will produce the electricity and it will charge your battery. So this is followed by Tesla, and there are few more cars. Okay. Yes. So even in India also there is one car, I don't remember what is the company name. So that car also started this, guys. You can try checking on YouTube. Okay. Yes. So if your car at here, if it's a charging is at 50%, once you are downhill, you can charge up to 70%. So you can increase 20%. So based on the distance and all those things. Okay. So in that way, charging is also possible. So this is a small example with this, guys. So here how you are getting minus 2 means you are getting profit, or you are getting something, right? If it is negative, yes. So I hope everyone got a clear idea. So now let us go through the glance about the algorithm. So Bellman Ford, G, W, S. So G is our graph, W is our weights, S is our source. So where we are starting. Okay. So for each vertex, you have drawn the table and you have initialized into infinity and nil. Okay. So first vertex you will assume as a source. Okay. So here we are not going to use any Q, guys, because previously why we are using Q? Because we used to cancel them, right? So for that reason, to take the minimum value, so we used to use a Q, but here there is no need of any Q, guys. Okay. Yes. So you will run the loop I equal to 1 until you have how many vertices? That many minus 1. So if you are having 5 vertices, you will do 4 times, guys, this operation. Okay, so what you will do is for each edge u comma v belongs to G, you will compare the edges and you will fill the table, guys. So if you recall, we filled the table by comparing, right? So which is minimum, which is minimum, which is minimum. So that exact concept you will do here. So once the whole filling is done, then you will start checking if there is any more further. So basically at the end you will end up with this result, right? But if you do one more time and if you are getting some results, so basically if it is reducing again, so let me just give me a second. Yes, here. Okay, so after 3 turns the result will be at S, A and B. Okay, so here the result will be 0, here the result will be 10, and here the result will be 30. But if I continue again, okay, so if I continue again, so again this will give a result of -1, right? Means it is better than 0, right? So if these kind of situations exist after the full completion, that will lead to a false, guys. So this false indicates that there is a negative cycle. Got it? Yes. So now I hope everyone got a clear idea with respect to the algorithm also, right? Yes. So this algorithm might seems a bit easy, right? Yes. So I hope everyone got a clear idea with respect to Bellman-Ford algorithm, right? So Bellman-Ford, how it is working. Okay. So this is the last lecture according to our syllabus, guys. Okay. Yes. So in the next lecture we'll be starting with the PYQPs, guys. Okay. So PYQPs of the whole subject algorithm. So once that is done, so the next subject which we'll be starting is a digital electronics, guys. So that is a subject which I am interested in. So that's the reason why I'll be starting that subject next. Okay. Yes. So I hope everyone liked the series of algorithms. So I hope everyone will be back and I'll be seeing you all in PYQP sessions, right? Yes. So in the next lecture, let us start solving the PYQP. The first PYQP will be of algorithms, asymptotic notations. Okay. Yes. So let us meet in the next lecture. Thank you. Thanks for watching. Like, share and subscribe for more awesome videos like this. Thank you.